first half of the unit, what were we looking at?
So we were taking, we were trying to figure out equations.
Well,
and
we figured out equations in 6A, and now we're in 6B. So 6B, we looked at what?
Okay, so the first part, we looked at different types, like the different types of reactions, like combustion or single replacement.
Yeah,
okay.
So we looked at a bunch of little groups that we can classify reactions into. We can actually classify all these little groups into a couple big groups.
Okay.
Reactions that involve transferring electrons between elements and reactions that don't.
Okay.
But to figure out which it is, we have to figure out whether electrons have been transferred. Do you remember what happened when electrons got transferred?
Oh, yes. We got charges. We got charges.
Okay, so let's say we've lost electrons. What kind of charge are we going to get?
Okay, we lost electrons. We got rid of electrons. We've got more positive charges than negative charges, so the charge is positive.
Right, so then if we gain electrons, we're going to get...
It's going to be negative, because now we've got more negatives. Okay.
And then we know that those charges, we can figure out looking at their groups, right?
Yeah.
Yeah, so most of the time, our oxidation numbers actually line up really closely with our charges. Sometimes they don't, though, so there's a few rules we've got to learn.
Okay.
So these are going to be our rules for assigning oxidation numbers, which, like I said, it's going to be a lot like our charges. So our very first rule is our easiest rule. If it's a free element, it's got to be 0. So if it's one element and one element only, the oxidation number is 0.
Okay, so like if I have aluminum metal, since it's just the aluminum, then that oxidation number is 0.
Right, because it hasn't lost or gained electrons yet. So, for example, what if we had H2? What's the oxidation number on H2 going to be?
Well, I guess since it's a free element, it would also be 0.
So, but it's H2. Is it still free? Is there any other element other than hydrogen there?
Oh, no.
So, as long as there's only one element, it doesn't matter if you have multiple of the same element, it's still 0.
Wasn't there a name for these?
Yeah, there were our diatomic elements. They always have to come in pairs.
Okay.
So some people like Brinkelhoff to remember it. Some people like to look at the periodic table. You start at 7, which is nitrogen. You go over and you go down, you make a 7. And that gets most of them. Then you also have to remember hydrogen.
Okay.
All right. So then our next one is calcium. And we went too fast. All right. So hopefully we can get this make sense. So our next example is calcium. So what is it?
Okay, it's just the calcium by itself. So it's 0.
Okay, but it's in group 2. And what do we know about group 2?
Well, those are always their charge is always +2.
But that's only when they're in compounds.
Oh, okay.
Yeah, so as long as it just says Ca and nothing else, it's a free element, and it's got to be 0.
Okay, awesome.
All right, let's look at our next rule. Our next rule is that metals have an oxidation number that is the same as their ionic charge. So if I had calcium in a compound, like calcium chloride, what would calcium's oxidation number be?
Then I would look at the periodic table and know that the charge is +2.
Right. So anytime it's in a compound, it's whatever the charge is supposed to be based on your group. So for sodium chloride, what's my oxidation number going to be on sodium?
When I look at the periodic table, sodium is in group 1, and so it is +1.
There you go. All right, and then let's look at our next one, which is aluminum bromide.
Aluminum, on the periodic table, aluminum is +3.
Because it's in group 13. There you go. And then we have Ag2O.
Oh, you know... silver, right? That's Ag is silver, but that wasn't in. That's not in a group that you can just get the charge. It's in the middle. The transition metals.
Remember, silver is a weird one. It's in the transition metals, but it can actually only ever have one charge. It can have a +1 charge.
Okay.
And so, anytime you've got silver, its oxidation number has to be the same as its charge +1.
Okay.
The reason why is beyond the scope of this course. All right, our next rule. Hydrogen is +1 in compounds. So if H shows up, it's going to be +1.
Okay.
Just go with it.
Oh, okay, I'm just going to go with it.
All right, and oxygen's always going to be -2.
Well, that one makes a little bit more sense. I mean, it's -2 on the periodic table.
Right.
Right.
Well,
okay.
and hydrogen, remember, is in group 1, so like the rest of the alkali metals, it can be +1.
Okay.
All right. So our next example does both if we've got water, H2O. We know oxygen has to have what oxidation number?
According to rule number 3, hydrogen has to be +1.
And then oxygen has to be?
Oxygen has to be -2.
According to rule 4.
Okay.
All right, so the last rule, if you can't figure it out based on one of the previous rules, you have to know that the sum of the oxidation numbers has to be 0 for neutral compound. This is just like ionic compounds. What's the total charge have to be an ionic compound?
0, neutral.
It has to be 0, it has to be neutral. The same rule applies for oxidation numbers. Remember, oxidation numbers are pretty closely tied to our charges. If we've got barium nitride, we've got 3 Ba's, we've got 2 N's. How did we get those numbers?
Okay, so if the overall charge has to cancel out, it has to be 0. But let's see, if I'm looking at the rules, Ba is a metal. On the periodic table, barium is in group 2, so that means its charge has to be +2.
So if we've got 3 bariums, what's the total charge from all my barium?
Let's see. 3, 2 + 2 + 2, 6. So overall it has to be 6.
Okay. And then nitrogen comes with what oxidation number?
Well,
we don't know.
That's right.
Because we don't have a rule about nonmetals yet.
Okay.
So if we look, nitrogen, actually, if you look at the periodic table, remember that group.
Okay, that's right.
They come with 5 valence electrons,
right,
so they've got
they're -3. Okay.
They're -3, but we know we're right because we have 3 + 2s is 6.
And if we've got 2 -3s, that's going to be -6. And then if I put those, we put them together, and it should be 0.
There we go.
Oh, okay, awesome.
Yeah. All right. So let's do some guided practice. So if you're figuring out what you're doing, take a break, try and do it on your own. If not, then come watch us and work through these with us.
Okay.